This video is on section 5.1 notes, measures of dispersion or variation is another word for dispersion. So I put definitions of both of these so you could see them and understand it better. So dispersion is the extent to which data points in a set are spread out or scattered around the average value. Variation is the degree of spread within a data set, how far apart the data points are from each other and from the mean. So it's just how different are the values? How different are they from the mean? How different are they from each other? How consistent are they? Might be another question you could ask. The range is the difference between the largest and the smallest data values in a set. All right, so the first example says to find the range of the heights of people listed in the table below. So we have the world's tallest person, the world's shortest woman, Joe Burrow and LeBron James. So we're going to compare the tallest person and the shortest woman, and it gives their height in feet and inches as well as their height in inches. And typically, if you're going to find the range in something or just be subtracting numbers, it's going to be good to have one unit of measurement. And so to find the range in these heights, we're just going to subtract. We're going to find the difference between the largest and the smallest. So 107 minus 24 is 83 inches. There's a difference of 83 inches in their heights, which we might be able to interpret more easily if we look at this version. 8 feet 11 inches minus 2 feet would be 6 feet 11 inches. So there's almost 7 feet of difference between their height, which is insane if you can picture that. All right, next we're going to talk about standard deviation and variance. Standard deviation is a statistical measure that indicates how spread out a set of data is relative to its mean. And when we say spread out, we're talking about how much it varies from the mean, how far away the numbers get from the mean. And then variance is talking about that spread, a measure of how spread out a data set is from the mean. So standard deviation and variance are directly related to each other. In fact, as we see here, well, we'll see it more later, but the standard deviation is denoted by S. It's the square root of this formula right here. Variance is this same formula, just without the square root. So they're directly related to each other. So this formula is one where we can't just take numbers and plug them into the formula and get the result. We have to calculate this formula in the form of a table. So this symbol right here is the Greek letter sigma, and it means that you are adding numbers repeatedly. So the inside of these parentheses mean you're taking one data value and you're subtracting that one data value and the mean. So the data value minus the mean, you're going to take that, subtract it, and then you're going to square that number. So you're doing that for every single piece of data in your data set. And then once you've done that, you add them all together. That's what the sigma means. And then once you have the sum of all of that, you're going to divide it. N would be the number of data pieces that you have. So here we have 5 terms in our data set. You're going to divide it by 1 less than that. So we're going to divide by 4. And then once you've done the division, you square root the whole thing. So this is not something where we can just pick up some numbers, plug them into a formula, plug it in our calculator and get an answer. We have to do all of the steps by hand. And this is something that I would expect to see on notebook paper. I'm going to see a lot of computations anytime you do standard deviation, and it asks you to use this formula and show your work. So here, the first thing we have to do is find the mean, because we need to know what x bar is, and that's what the mean is. X bar is like the shorthand or the variable that we use to represent the mean. So I'm going to go ahead and find the sum of these data values. There are 5 of them. So the sum is 85. And I'm going to divide it by 5, and I get 17. So the mean is 17, and this is x bar. All right, so now I'm going to take each of these data values and I'm going to subtract the mean. 16 minus the mean, 14 minus the mean, 12 minus the mean, 21 minus the mean, 22 minus the mean. And then once I figure out what this is, I'm going to take the resulting number and I'm going to square it. So 16 minus 17 is -1, and I'm going to square that. -1 times -1 is 1. 14 minus 17 is -3. I'm going to square that. I'm going to get 9. 12 minus 17 is -5. I'm going to square that, and I'm going to get 25. 21 minus 17 is 4. I'm going to square that, and I'm going to get 16. 22 minus 17 is 5. I'm going to square that and get 25. Okay, so we have done the x minus x bar. We've done the x minus x bar squared. Now we have to do the sigma part where we add all of these together. And when you do x minus x bar squared, you should get all positive numbers because square numbers are always positive. So I'm going to take this sum. 1 plus 9 plus 25 plus 16 plus 25 is 76. And then I'm going to do the square root of 76 divided by 4. There's 5 numbers here, so I'm going to do one less than that. So the square root of 76 divided by 4 is S, which is the standard deviation. So the square root of 76 divided by 4, 4 point, and in my math lab, as you're doing these problems, it should tell you how many decimal places they want. And throughout these notes, I'm just going to write 2 decimal places. So 4.36. Okay, now if that felt like a lot to remember, the steps are written out on the previous page. Okay, so you follow the formula, which means that you're just doing each of these steps. Okay, so let's try it again. Here we are planning for spring break, and we want to, we're going to go to orbitz.com to find the cheapest flight from Philadelphia to Orlando. Here are the different prices, and we want to find the standard deviation of this data set of these prices. So I'm going to find the mean first. So 1,260 is what I get when I add up all those prices together. And I'm going to divide by 6 because I had 6 prices. So 210 is the mean that I got, and so that's going to be my x bar. And now I'm going to do the data value minus 210. 213 minus 210. 208 minus 210. 219 minus 210. 210 minus 210. 215 minus 210. Now I'm going to take the difference and I'm going to square it. So 195 minus 210 is -15 squared, and -15 squared is 225. 213 minus 210 is 3 squared, which is 9. 208 minus 210 is -2 squared, which is 4. 219 minus 210 is 9 squared, which is 81. 210 minus 210 is 0 squared, which is 0. 215 minus 210 is 5 squared, which is 25. Now I'm going to add all of these up. 225, 9, 4, 81, and 25. and I get that my sum is 344. So my standard deviation is the square root of 344 divided by 1 less than the number of pieces of data that I had. I had 6 pieces of data, so I'm going to divide by 5. So 8.29. The higher the value is for the standard deviation, the more spread, the more variation the data has. The smaller the number for standard deviation, the less spread or the less variation the data has. It means more of the numbers would be closer together. All right, so here we want to learn how to compute the standard deviation for a frequency distribution. Now, typically, you would not create the frequency distribution and then find the standard deviation for it. Normally, if I had a set of data, I would just find the standard deviation from the set of data. However, they gave us the data here, and we're going to do both in the same problem. So here's our formula. We're going to work with it in a second. It says Anya is considering investing in Appeal, a software company that specializes in smartphone apps. Get it? Appeal. Okay, that's fine. She intends to compute the standard deviation of its recent prices to measure how steady its stock price has been recently. The following are the closing prices for the stock for the past 20 trading sessions. So, and we're going to be calculating the standard deviation for the data set. So we have to calculate the frequency for each of these. So I'm going to kind of do a tally for each one. So 37 is used once, 38, 1, 2, just twice, 39, 1, 2, 3, 4, 5, 40, 1, 2, 3, 4, 5, 41, 1, 2, 3, 4, 42, 1, 2, and 44, looks like it's just 1. Okay, so there's our frequency. Now in the table, it's not in the formula, but in the table they're asking us to find the product of the data point itself and the frequency. And so I'm going to go ahead and do that. We've got 37 times 1 is 37, 38 times 2, 76, 39 times 5, 195, 40 times 5, 200, 41 times 4, 164, 42 times 2, 44 times 1 is just 44. Okay, now if we add up the frequencies, then it's going to tell us how many numbers we have here. So 1 plus 2 plus 5 plus 5 plus 4 plus 2 plus 1, 20. So there's 20 pieces of data that we're looking at. If we add up the products here, then that tells us it's a shortcut way, kind of shortcut, not very short, but it's a shortcut way of us adding all of these numbers together. So what we're doing is we're kind of finding a grouped mean, but we're adding up all of these numbers together. We're finding the sum. So the sum of all of these numbers was 800, and we have 20 numbers all together. So 800 of the sum divided by 20 numbers all together means that the mean is 40. So 40 is x bar. So to find the deviation from the mean, sorry, my phone just rang. So to find the deviation from the mean, we're going to calculate the x minus x bar. We're going to calculate each of our data values minus the mean. So this next part that we're doing is going to feel a lot like what we did on the previous page when we were doing the table for standard deviation. So we have 37 minus 40, 38 minus 40. We're just subtracting the mean. 39 minus 40, 40 minus 40, 41 minus 40, 42 minus 40, 44 minus 40. So 37 minus 40 is negative 3 squared, which is 9. 38 minus 40 is negative 2 squared, which is 4. This is negative 1 squared, which is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And then this is 4 squared, which is 16. Next, this is going to be a little different from the previous page because they're saying find the sum of all of these. But when you find the sum of all of these, you're not going to find the sum of this part of the table, of this column. You need to multiply them by the frequency first and then find the sum of everything. So I'm going to take this and I'm going to multiply it by the frequency. So 9 times 1, a frequency of 1 is 9. 4 times a frequency of 2 is 8. 1 times a frequency of 5 is 5. 0 times a frequency of 5 is 0. 1 times a frequency of 4 is 4. 4 times a frequency of 2 is 8. And 16 times a frequency of 1 is 16. And then it says, once you have done this, now you can find the sum of all of that. So that's what we're going to do. We're going to find the sum of this. 9 plus 8 plus 5 plus 4 plus 8 plus 16 is a sum of 50. Okay, now it says to take that sum and divide it by the number of data pieces that you had, almost, not the number of data pieces, just one less than the number of data pieces you had. So the standard deviation is going to be 50 divided by 1 less than this, so divided by 19. .62. All right, next we're going to find the coefficient of variation. The coefficient of variation is a measure that represents the ratio of the standard deviation and the mean of the data set. So it compares them to each other. And it's the standard deviation divided by the mean. That's the ratio. And then you multiply it by 100. So you're turning it into a percentage. So we're going to do this for 1 example problem. It says find the mean and standard deviation of the data in the table below, and then find the coefficient of variation and determine whether Facebook or Twitter had more consistent closing stock prices during the first 6 months of 2020. So if there is less variation or a smaller percentage for the coefficient of variation, then that's going to mean that that the closing stock prices were more consistent. So that would be kind of your goal for your business, would be consistency. You wouldn't want your stock prices to be volatile, because that means you have a lot of bad days. You could have good days, but bad days are not what we want. So here, I'm going to show you guys how to use a graphing calculator to find the mean and to find the standard deviation quickly. And this is something you can do in problems where it allows you to do that. If I don't say that you have to show your work for standard deviation or the mean, then you could use this as kind of a shortcut method. So if you have a graphing calculator, you can use that. If you have a scientific calculator, then I believe that they still do this, but the process would be a little bit different. So send me an email or let me know if you want to meet on Zoom, and we can talk about how to do this in a scientific calculator if that's what you have to work with. So to do this in a graphing calculator, you're going to hit the Stat button because we are doing statistics, and we are going to edit. And it allows you to plug in a table. So I'm just going to start plugging in the values from this table. 201.91, and then I'm going to hit the down arrow. 192.47, 166.80, 204.71, 255.09, 230.77. And then once I've plugged the values in, I always look at them again and make sure that my values are correct. So once I've done that, I'm going to hit the Stat button again, and I'm going to go to the right to calculate, and we're going to calculate one variable statistics. So I'm going to press enter, and then I'm going to press enter for all these things. So enter, 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 and it's going to put up all this information for me. X bar is the mean. S is the standard deviation. And because I don't want to round any answers yet, I'm going to write down as many decimals as I can, because I need to take these numbers and I need to plug them into my formula for my critical value, or sorry, not my critical value, my coefficient of variation. My coefficient of variation is S divided by X bar. So I'm going to write down as many decimals as I can so that I can plug that in a second. So I have X bar is 208.625. And S is 30.725, 00724. Okay, and then my coefficient of variation is just the standard deviation divided by the mean. This is a ratio right now, so if I want to write it as a percentage, which I do, I'm going to have to multiply by 100. Okay, so I have 14.7% is my coefficient of variation. That's how much variation I have. I'm going to go ahead and calculate it for Twitter as well. So to clear the memory on my calculator, I'm going to hit the blue button second, and then the plus sign, and then 712. And now if I hit the Stat button and go back through the process again, all of these are cleared out. And you don't have to clear them out, you can just write over them, but I like to have the boxes empty. So now that I've got them in, I'm going to hit Stat, go over to Calculate, one variable statistics. My X bar is 30.79. And then the standard deviation is 3.704266009. And I'm going to do the standard deviation divided by X bar divided by the mean. And then this is a ratio currently. I'm going to multiply it by 100 to make it a decimal, or just, not a decimal, sorry, a percentage. Or I could take the decimal and move it over twice. So 2.0%, 12.0%. So this one has a higher percentage, so that means it has more variation. This one has a lower percentage, that means it has less variation. Less variation is more consistent, and so Twitter was more consistent.